Okay. So completing the square, like I said, it was something you saw in Algebra 1, but we're going to start small first, learn the steps, and then once we get the main part that's done, then from there, we're just doing examples, okay? The more examples you do of these, the better you're going to get and the more natural it's going to become, okay? So it might seem like a lot of examples today, but it's a good thing, okay? So I'll help you with the repetition. So our main goal is this x plus h squared. You don't have to write this down. Yesterday, what we did is we had x plus 2 squared equals 4 or something like that. That's our main goal today. We want our equations to look like that, so then we can then solve by square roots what we did yesterday, okay? So we're going to start small. They want us to figure out what's going to go in that blank, and it's a really tiny, tiny formula that is as simple as b divided by 2 squared. B divided by 2 squared. Okay? So watch how this formula helps us. If we take our b value, which in this case is 22, divide it by 2 and square it. Now, the next part will look like a waste of time, and I get that, but it's going to help you. And what I mean by that is, if I actually show my work, doing it that way is going to help you with the next part, okay? So b divided by 2 and square it means we get 121. Okay? So if I asked you to take this question further and say, okay, what are 2 numbers that multiply to get 121 but add to get 22? What would you say? 11 and 11. Instead of writing x plus 11 times x plus 11, can't you write x plus 11 squared? And that's exactly what we want, okay? So the reason why showing your work is helpful, there's your answer right there. So if I ask the question, b divided by 2, and then I say, okay, 2 numbers that multiply to get 121 to add to get 22, it's going to be right there every time. Okay. Every single time, which is helpful on the next problem. You don't need a calculator. I'm going to do negative 7 divided by 2 and square it. I can square the numerator and I can square the denominator. So this just becomes 49 over 4. Okay? So then if I had to ask myself the question, what are 2 numbers that multiply to get 49 over 4 but add to get negative 7? What? Okay, that's not something that's natural like the other one, 11 and 11. Okay? But because I showed my work, it would be negative 7 halves. Okay? Negative 7 halves times negative 7 halves is a positive 49 over 4. Negative 7 halves and negative 7 halves added together gets me negative 7. Okay? So if I show my work every single time, that next step in solving, when I ask you the factors, is right there for you. Okay? Any questions on that so far? So from here on out, we are doing examples. And I suggest that you do every single one of those examples. I suggest you do every single one of those examples. That's my mouth moving behind the mask. I was whispering. Okay, so here we go. The average person, I wouldn't say the average person that's good at math would look at that and say, oh, I can factor that. I know factors of -3 that add to get -2. I'm done. Okay. I don't need to do completing the square. But today is focusing on completing the square. All right. So first thing you're going to check for is A equal to 1. You cannot complete the square unless A is 1. You can manipulate it so that A equals 1, but you can't just jump right into completing the square if A is not 1. Okay? Next step, move your C value over, and then we're going to add blanks. Okay? So what I mean by that is I'm going to move my C value over, and I'm going to add a blank on each side. Why would I add a blank on each side? Okay, so here's the thing. I can manipulate a problem all day long as it keeps the equation true. So if I want to add 12 to one side, I can add 12 to the other side, and it still doesn't change the value of the problem. Okay, so we're manipulating these to make them look a certain way. So we can't just add one thing because we want to. We got to add it to both sides. Okay. So that's why I do a blank on each side, okay? So what is that blank for? That last slide we've been doing. I'm going to do B divided by 2 and square it. There we go. Okay, so my B value in this case is -2 divided by 2 and square it. So I get -1 squared, which is 1. So that's what goes in those blanks. Okay. So now we're going to factor. What are two numbers that multiply to get 1 that add to get -2? -1, -1. So I'm simply just going to write x minus 1 squared. And then I'll do my 3 plus 1. Now we're down to what we did yesterday. How do you get rid of a square? Square root it. Go ahead and finish this problem out. Okay, so once we get it down to what it looked like yesterday, things should move pretty quickly, okay? But that's why I did the steps off to the side. I also want to encourage y'all to start doing stuff like that in your own notes if I don't do it every day, okay? I want y'all to put those little steps off to the side. Those are the steps I'd probably put on that one sheeter, okay? For those of you who like doing that. How do I complete the square? But honestly, with completing the square, the more you do, the more you're going to remember, okay? So if it turns out pretty like this one did, with the 3 and the -1, yeah, I could have factored it, okay? But I'm simply just getting y'all familiar with completing the square, okay? Any questions on that one?
Are there any specific cases where it would be better to do this over factoring or the other way?
So there'll be cases where you can't factor. And so what I normally do on tests, my test for this chapter, is you have, I think it was 6 or 7 different problems. And I said, you can only use each method once. And so you would kind of scan through what we learned yesterday, solving by square roots. That one would kind of be obvious because it would just be no B term. After that, I would do the factoring problem because not every problem can be factored. And then I would look for completing the square ones. And then from there, I would leave graphing and quadratic formulas the last ones. But yeah, if you can't factor it, completing the square, if it's something that turns out to be pretty with your B value being even, then yes. But if it turns out where you kind of like that one example we did where it was a fraction, I probably wouldn't want to do completing the square. Can you do it? Absolutely. Is it more work? Yes. Good question though. Any other questions? Okay, let's try this one. I'm going to walk you through this one again. Like I said, we're going to do a ton of examples. So at one point I'm going to set y'all free, but I'm going to walk you through another one. So I look at it and I say, okay, great. My A value is 1. I'm going to go ahead and move my C value over and add in my blanks. To fill in my blanks, I'm going to do B divided by 2 and square it. B in this case is 18. So 81 will go in my blanks. Okay. From there, I need to factor and simplify. 2 numbers that add or multiply to get 81, but add to get 18. 9 to 9, so I just write x plus 9 squared. And then 27 and 81 get me 108. Now I continue to solve. Some of us might not realize a perfect square that goes into 108. So maybe I go to the division and I start dividing. So I take the square root of both sides, include my plus or minus. Let's go ahead and tackle 108. So if I divide that by 2, I get 54. Divided by 2, I get 27. 3, I get 9. And 3, I get 3. Unless you knew automatically that 36 was the perfect square that went into 108, that's great. If not, take the guessing out of it. Okay? So I have 1 pair of 2s and 1 pair of 3s. So 2 times 3 gets me 6 on the outside. And then this 3 stays on the inside. And the last step to getting x by itself is I subtract 9. Looking at this particular problem, I could not have factored that. Okay, that's pretty obvious. I ended up with the square root in my answer. I was not able to factor that one. Okay. So again, what we learned on, what was that, Monday? Okay. What we learned on Monday, reducing radicals and simplifying, that's what we're doing on these last parts. Yes?
So will the number like 108, will it always have a perfect square?
Not always. And if it doesn't, you would just leave it as plus or minus the square root of 108. Good question. If it can't be simplified, it can't be simplified. If it can, the expectation is that you take it down to that. Any other questions? Okay. Go ahead and try this one. The more examples you do, the more it will become natural. Start getting yourself away from the steps or referring to a problem we've already done. Okay, so I moved my C value over. Add my blanks. To fill in my blanks, I do B divided by 2 and square it. I plug 49 into those blanks. I asked myself the question, two numbers that multiply to get 49 but add to get negative 14. Negative 7 and negative 7. I like when a perfect square appears. So now if I take the square root of both sides, I get x minus 7 is equal to 3, and x minus 7 is equal to negative 3. So x equals 10, and x equals 4. Any questions on those? Does anyone want to share where we're making little mistakes or anything like that, or having little bumps in the road? It could be helpful to others who are willing to share. I know some students were forgetting the plus or minus on the 9, and they were forgetting to do both equations, so they only had one answer. Remember, we should have at least 2 answers. Okay. All right. Go ahead and try these 3. Repetition, repetition. Once we finish these 3, we're going to do some examples where A is not 1. I know you did it, but don't make the parentheses. So you don't accidentally say that's negative 4. It just sticks. How many of y'all are done or are on the last one? Okay, cool. All right, so the more I say these steps in my head as I'm working through the problem, sounds like you're talking to yourself, but the more they'll stay in there as well. So I'm gonna move that C value over and add my blanks. So if I am adding 54 over, 54 minus 8 gets me what? 46. Okay, so what goes in my blanks? I take my B value, divide it by 2, and square it. Get 4. So then two numbers that multiply to get 4, but add to get negative 4. Negative 2, negative 2. And I get 50 over here. Take the square root of both sides. Now, if you've noticed, I'm doing color-coded this time. If you're somebody that has a hard time looking back on your notes, figuring out what happened when, because I take the square root on both sides, on the same step as I wrote this, sometimes that can get a little confusing. So if you're someone who likes color codes and knowing, oh, okay, I did that on a separate step, I just didn't want to write it twice kind of thing, I encourage you to do that. So x minus 2, if we reduce the square root of 50, I know that the square root of 25 is a perfect square. 25 times 2 gives me 50, so 2 root 5, or 5 root 2. Just went a little backwards there. You could also divide that out, and you would also get 5 root 2. Add my 2 over. And I have completed the square. Okay? And solve for x. Still getting 2 solutions. Still getting, so 2 plus 5 root 2 and 2 minus 5 root 2. Still getting my 2 answers there. Okay? Move my c value over, add my blanks. b divided by 2 and square it. So I get 8 squared, which gets me 64. 64 minus 48 was what? You what? 16. So then we get x plus 8 over here squared equals 16. Take the square root of both sides. This one turns out pretty, and I like it. So I get x plus 8 equals 4, and x plus 8 equals negative 4. Subtract my 8. I get x equals negative 4, and x equals negative 12. Okay, so far we've gotten an answer with a radical, and we've gotten an answer where it's pretty. We're missing one special one that we've been learning this chapter. That's our imaginary ones, okay? So, move my c value over. Add my blanks. b divided by 2 and square it. Add that to my blanks. What is negative 72 plus 49? Negative what?
23.
Negative 23. Not even pretty. So x plus 7 squared gives me negative 23. I take the square root of both sides with my plus or minus, and then I'll subtract my 7. So I should get x equals negative 7 plus or minus I square root of 23. So that right there is 3 different types of answers you will see. You'll see ones that turn out pretty, ones that have a radical, and ones that have an imaginary number. Any questions on any 3 of those? Okay, let's take a quick break, and we're going to do where A is not 1. Those are a little bit different. All right, let's go ahead and come back. Little brain break. And we can still complete the square when A is not 1, but we gotta fix it first, okay? So you're still going to move your C value over, but don't write your blanks just yet. Okay, so looking at the left-hand side, what's the greatest common factor? 6. 6 goes into 6 and it goes into 12. So what if we factored out a 6? Okay. Now add your blanks. So what we're technically completing the square with, not the scare, that's actually like a Halloween joke or something like that. Completing the square, we can do that on the inside of the parentheses now, okay? So I take my B value, divide it by 2 and square it. So I get 1. We're manipulating the equation. We're not changing the value. What do I need to put over here on the right side? 6. This 1 is still attached with being multiplied by 6. Okay? So we can't just do like the other problems, copy paste. I just put what I put here and I put it over there as well. Okay? So these are a little bit different. This is 6 times 1. So in order for this problem to not be changed, this needs to be a 6. I have 6 on both sides now. Yeah.
So, what if what if one was a 2? Would the 6 by 9 be a 12, or would it still be 6?
Yeah, it'd be 12. So if this number 1 right here was a 2, you would do 6 times 2, which would be 12. Yeah. Okay. So what are 2 numbers that multiply to get 1 but add to get 2? 1 and 1. And can we go ahead and jump to taking the square root of both sides? No, we got to divide by 6. Now, I heard the argument in 7 a.m. Well, couldn't I have just divided everything on this first blue line by 6? Sure. The only problem is that doesn't work for every problem. What I mean by that is, what if this 90 was a 41 or something like that, okay? So I wanted y'all to be familiar with how to solve every problem. But if you can find shortcuts like that, great. If not, you can all solve them the same way. And what is 96 divided by 6? 16. And we continue solving it like we've been doing. So it requires a little bit more paying attention because you have to make sure that you are making the equation still equal, okay? And we just got to make sure we multiply. So if we have x plus 1 equals 4 and x plus 1 equals negative 4, we get x equals 3 and x equals negative 5. Okay? So do not forget, if you have to take out a leading coefficient, that leading coefficient is also multiplied by your b divided by 2 squared. Okay? Questions on this? If you're sick of doing these problems, that means you understand it. Or you're just tired. Either or. Okay, try this one. Still going to start off moving our C value. But then we're going to have to manipulate it just a little bit. Still add my C value over. Now I take out my A value, which conveniently is going to be my greatest common factor. Someone might ask the question, well, what if it doesn't go into everything evenly? It is still doable. It's just ugly, okay? If you have an option to do another method, I would. But if you are forced to do completing the square, you just got to go with the ugliness of it, okay? If it's fractions, it's fractions. Okay, I take b divided by 2 and square it. Negative 3 squared gets me 9. But what goes over here to the side? 27. Okay, so 3 times x minus 3 squared. And negative 36 and 27. Negative what? 9. Negative 9. Divide by 3. Take the square root. So I end up with x equals 3 plus or minus I square root of 3. Okay. How do we feel about this? Okay. Don't worry. We have a couple more examples. It's good for you. My mom used to say that all the time, especially about food. She would be like, try it. You might like it. It's good for you. Both my parents were chefs, so I had good food coming my way, but at the same time, I was still a picky eater. Okay, go ahead and try these two. On your own, all the way through. Just trying to make it so y'all can see the second one so y'all were dodging for it. All right, so for time, I'm gonna go ahead and go through these really quickly. So add over my 83. I take out my 2. I divide -6 by 2, that gets me -3. -3 squared is 9. So then I get 2 times x minus 3 squared, gives me 89.
Shouldn't be 18.
Should be what?
2 times minus 18.
Oh, thank you. I made the mistake. Like, that doesn't sound right. 18, thank you. So then I get 98. That's a whole lot prettier than what I was going to come across. 98 divided by 2 gets me what? 49. Take the square root of that. I get x minus 3 equals 7. And x minus 3 equals -7. So we should get 10 and -4. Okay. And then the second one, if you got to the third one, great, and you want me to check it, but the second one is what was expected. So if I take out a 10, I get x squared plus 2x plus blank equals 90. And 2 divided by 2 squared, I get 1. So over here, I should get 10. Another perfect square one. This is nice. So I get 10x plus 1 squared equals 100. But then, unfortunately, that 10 takes that away from me. Okay, so if I divide by 10, I get x plus 1 squared equals 10. Take the square root of both sides. Good news, I don't have to simplify the square root of 10. So my answer is just simply -1 plus or minus the square root of 10. Okay? Any questions on those two? Okay, let's go ahead and clean.